Day 2, Logic and Reasoning. Today we will define and identify converse, inverse, contrapositive, and biconditional statements, and we will practice writing examples of each kind. A conditional statement is a logical argument that has two parts, a hypothesis and a conclusion. In our example, if the weather is rainy, everything after the word if is the hypothesis. We use the letter P to represent hypothesis. Then there are clouds in the sky. Anything after the word then is the conclusion, where you use the letter Q to represent conclusion. In example 1, you need to rewrite the conditional statement in if-then form. Example A, all birds have feathers. So we always start with if, and we know we're talking about birds having feathers. So if an animal is a bird, then it has feathers. For part B, two angles are supplementary if they are a linear pair. Here I already see the word if, so I'm going to use everything after the word if as my hypothesis. Everything before will be my conclusion. All right, so we have if. Here it says they. We don't know what they is. They is referring to the two angles. So if two angles are a linear pair, then they are supplementary. The negation of a statement is the opposite of the original statement. So negate, think negative, opposite. Statement 1, the ball is red. To negate the statement, you would need to write the ball is not red. Statement 2 already has the word not. The cat is not black. To negate, you need to eliminate the word not. So the cat is black. Now let's discuss the different types of statements and how to write them. The converse, you need to flip the hypothesis and conclusion. So you will see conclusion implies hypothesis. For the inverse, we leave the order the same, but we negate. Negate hypothesis and conclusion. For the contrapositive, we are going to flip the order and negate. So you will have negate, conclusion, implies negate, hypothesis. So flip the order and negate both conclusion and hypothesis. Finally, for the biconditional statement, we are going to write the hypothesis, if and only if conclusion. So for the biconditional statement, we have two of the word if. So remember, if and only if, biconditional. There is no if and then form like the other statements. All right, let's look at some symbols. We know we like symbols in math. Our first symbol, we have an arrow pointing to the right. We would read this as implies. The tilde or the squiggle would mean negation. So when we see this symbol, we say not P. And it's written like this. The 3 points that form a triangle means therefore. So when we see this symbol, we're going to read therefore. All right, let's write our symbols for each statement. Conditional statement is the original statement. So we'd have P implies Q. For converse, we are going to flip the order. Conclusion implies hypothesis. For the inverse, we are going to negate the hypothesis and negate conclusion. So we read not P implies not Q. All right, for contrapositive, we are going to flip and negate. So not Q implies not P. And finally, for the biconditional, we need to add one more symbol to our notes. Arrow in both directions means if and only if. So we have hypothesis or P, if and only if, conclusion or Q. Let's look at an example. Let P be the car is running, and let Q be the key is in the ignition. For part A, wants us to write the conditional statement, P implies Q in words. Okay, P we have up here is the car is running. So we're going to write if the car is running, then, and we have Q. Q is the key is in the ignition. Then the key is in the ignition. So all we need to do is look at the symbolic notation, our symbols, and write the sentence or the statement. Let's look at example C or part C. write the inverse in words and symbolic notation. Let's write the symbolic notation first. So inverse, if we look over here, says it is not P, implies not Q. So we keep the order, but we're going to negate. So if the car is not running, then the key is not in the ignition. I want you to try B and D on your own. Let's go down to example 3. We have a picture. It says perpendicular lines are if two lines intersect to form a right angle, then they are perpendicular. So here we have a picture showing it's perpendicular by our square. Down below, it even says M is perpendicular to N. We need to know this symbol. It is very important. This symbol, upside down T, means perpendicular. You will see this on a test, and you need to know this symbol. Let's write the converse. The converse, if you remember, is when you flip the conclusion and the hypothesis. So let's go up to our statement. After the word if, we have the hypothesis. After then, we have the conclusion. So we need to flip P and Q. So we are going to write if, and it says they are perpendicular. What is they we are talking about? So they is talking about the two lines. Okay, if two lines are perpendicular, then now we can say they. Then they intersect to form a right angle. Let's look at the biconditional. We are going to use our original conditional statement above. If two lines intersect to form a right angle, then they are perpendicular. But we are going to eliminate the words if and then. So first, let's write our hypothesis. Two lines intersect to form a right angle. Now, between our hypothesis and conclusion, we are going to write if and only if. Two lines intersect to form a right angle if and only if they are perpendicular. Be sure you put if and only if in between the hypothesis and conclusion. Do not write if and then. I want you to try example 4 on your own, but it is important to note that the contrapositive has the same truth value as the conditional statement. This is known as the law of the contrapositive. What does it mean when we say same truth value? This means if the conditional statement is true, then the contrapositive is also true. So all this really means is that if the conditional statement is true, when we write the contrapositive, it is also going to be a true statement. Which also means if the conditional statement is false, then the contrapositive is also false. So they go together.